Welcome and hello. This is a video exercise in HEC RAS, and in this exercise, we're going to be dealing with gates. Gates are part of inline structures, specifically gates controlled by water elevation and time series data. All right, so let's go ahead and get started. I've got my HEC RAS up. I just opened it up. So first things first, File, New Project, and then navigate to the directory you want to save your project in. Okay, so once you've done that, go ahead and give the project a title. I'm just going to call mine exercise 14 and OK. Okay. Down below here, I have the geometric data opened up, and I'm going to click on river reach and just single left click to start the river reach sketch in the direction of flow, and then a double click to end the reach, and then give that river and reach a name. I'll call it river A, reach 1. All right, next I'm going to click on the cross section and add some cross section data. Options, add a new cross section. The first one I'm going to input is going to be at river station 0, so I'll click OK. And then for the station and elevation data, I'm going to start typing that in here. And then I'm going to finish at 90 feet. Over here, the downstream distance is just going to be 0 for the downstream most cross section. And then for other cross sections further up the reach, we will have positive distance in for these fields. All right, the Manning's end value I'll just set to 0.05 and 0.03 for the overbank and the main channel respectively. And then for the main bank channel station on the left, it's going to be 300, and then on the right, it'll be 700. Okay, if I click Apply Data, you'll see a little preview of the cross-section right down here on the right side. All right, I'm going to add another cross section manually at the top of the reach here. That'll be 1,000 feet upstream. So to do that, I think the quickest way to do so manually would be Options, copy the current cross section. For the river reach, I'm just going to say 1,000, and then I'm going to put 1,000 right here, and then here, and here. And then also what I want to do is increase the elevation. So let's just add 10 feet for a 1% slope. Option, adjust elevation, 10. Okay, and now these values have all increased by 10 feet. We'll click Apply Data and then Close, and now we see our two cross sections here in the Geometric Data Editor. Next, I want to add a few intermediate cross sections because what I'm going to be doing in this exercise is adding an inline structure and then adding a gate. But before I do that, I want to add a cross section that's immediately upstream of the inline structure and immediately downstream of the inline structure. So I could do that manually, but another way I like to do it is to go to Tools, add some interpolated cross sections. That way the channel slope will remain constant. And I'm going to add a few more cross sections than I need here and then delete the ones I don't need. For the maximum distance, I'm just going to say 50 feet. So that's going to add a cross section every 50 feet. And I know that's probably overkill, but I'm going to go back and then remove most of them. This will be for the entire River A Reach 1 segment for all river stations. So interpolate cross sections and then click Close. Now we have a bunch of new cross sections. And where I'm going to put this inline structure is going to be between river station 300 and 350. So I'm going to delete 50 through 250 and then 400 through 950. And to do that, I'm going to open up the cross section editor once again. Options, delete cross section, and oops, I need to go ahead and position myself on a cross section I want to delete, such as this one, 50. I'll go Option, delete cross section, and then this is just a confirmation, and poof, it's gone. Okay, so it'll disappear right here once I close the editor, but I have to do that a bunch more times, so I'm going to go ahead and take care of that right now. Next up is cross section 100, delete cross section, yes, yes, and then that's gone. All right, that is the last one there. Let me just make sure that my image updates correctly. That looks good. So I've got 4 cross sections now, and they all have the same slope between them. So I can go plot profile, and then boom, river station 0, 300, 350, and 1,000. All right, looks good. While I'm here, I'm going to go ahead and look at river station 350. And then just observe that the elevation of the overbank here, both left side and right side, is 63.5. I'm going to need that in just a moment because the next step is to add an inline structure. So I'll click on inline structure, and then what I want to say is Options, add new inline structure, and I'm going to put this at 345. Oops, that's 245. 345, and then click OK. So if I zoom in on the plot here, what I'm going to do is put the inline structure just 5 feet downstream of this 350 cross section, and I'll make it, say, 40 feet long, or I guess wide in this case, so that the downstream face is just 5 feet upstream of the next cross section at River Station 300. Okay, let me zoom out here. And then here's the inline structure data editor. I'm going to click on Weir embankment. This is where I need to insert some of that data. So the distance is going to be 5 feet downstream from River Station 350. The width is going to be 40. And then in the station elevation data right here, this is where I'm going to need that 63.5, which is the elevation of the overbank. So let's see. River Station, I believe it was 300 for the leftover bank, and then that would be 0, and then 300, 63.5, and then 700 is the right overbank. We'll be able to preview this in just a moment to make sure that it's correct. It's, of course, based on that geometry. Right, so let's do a side slope of 2 to 1, and then click OK. All right, so that looks correct here. We have the Weir embankment that's been walled off for the main channel. And this is the wall that we're going to put our gates in. And that's the next step. So I'm going to click on gate right here. And this is the editor for us to add gates to our inline structure. What you notice at the top of this editor, it says gate group. So gate group 1, it already started me off on one gate group. I can add new gate groups, rename, delete, and copy. So let's go ahead and add a gate group right down here towards the bottom, and then a second gate group further up. Let's go with the sluice gate, and then I'll just go with the 0.5 for the discharge coefficient. Most of these default values I'm not going to touch. I'll just accept them as they are. So 0.8 is fine. Block crested weir and coefficient in case there's overtopping. That's fine. Now here's some of the dimensions of each individual gate. So what I've decided to do here is I'm going to actually have 5 gates on the bottom row and another 5 gates on the top row. But they're going to have the same height and width for each gate. The only difference between the different gate groups will be this invert elevation. So for the height, I'm going to say this is 8 feet high for each gate and 20 feet wide. The first gate group is going to be the lower gate group. That's going to have an invert of 35. And then down here, I'll put the gate openings. So I'm going to just say G1 is gate 1, G2, and G5. And then for the stationing, that's going to go left to right. So 400 to 600, somewhere in this range right here. I'm going to put the first gate at 440, 470, 500, 530, and 560. Okay, so I'm going to click OK and just see what that looks like. All right, so the image has updated. I see my 5 gates right here. They are actually going to be wider than they are tall, but because the scale of station versus elevation is different, they actually look taller than they are wide. All right, thankfully, we can make a copy of this gate group and just change the invert to create a second gate group just above it. So to do that, I'll open up this inline gate editor once again. I have my gate group number 1 already started. I'm going to click copy. It gave me a gate group 2 and it copied over everything automatically. So if I want to edit gate group 1, I can select that. Gate group 2, I'll select that. What I want to set the invert for gate group 2 is 48. So let me go ahead and click OK, and boom, there's my second gate group. So gate group 1 and gate group 2. All right, well, I think that's it for the geometry data. How these gates operate will be determined when we insert the flow data or the boundary conditions. So I'm going to close this and then go File, Save Geometry Data. I'm just going to call this the title base since it's going to be the only geometry file we used. And you can see if we zoom in, we have our inline structure that fits nicely between River Stations 350 and 300. All right, the next step is to add some unsteady flow data. So I'm going to go up to Edit, Unsteady Flow Data. And then what I'm going to do here is I've got 3 different boundary conditions I need to define. First, there's the 0 cross-section, 1000 cross-section, and then there's the inline structure. Let's start at the bottom here, which is River Station 0. I'm just going to go with the normal depth and then type in 0.01 for that 1% slope. Okay, that's done. Then let's go to the top. This is going to have a boundary condition of a flow hydrograph. So I'm going to click flow hydrograph and then make sure the radio button for enter table is clicked. We're just going to manually enter some data right here. Now what I want to do for the radio button is use simulation time, which means that this flow data will begin at the time the simulation begins. The data time interval will be 1 hour. Now, by default, the number of ordinates starts off at just 100, but on my clipboard, I have copied 240 hourly flow data, or 241, because it's going to be hourly flow for 10 days. That's 240 hours. So I'm going to click on number of ordinates, increase this to about 250. That's more than I need, but that's fine. I'll click OK. And if I scroll down here, now I have 250 rows. So I'm going to scroll to the top, highlight them all, and then on my keyboard, Control V should paste. And yep, that looks good. So let me scroll to the top. And then if you want to see what this data looks like, I do too. I'll click Plot Data just to confirm, and it looks good. What we're doing here with the flow is starting off at 0 and then increasing up to 5,000 CFS, holding steady for about 8 hours, and then increasing again to 10,000 CFS, holding steady 15,000, 20,000, 25,000, and then we ramp down back to 10,000 CFS. So this is 10 days of duration on the horizontal axis. And the vertical axis, it's flow rate and CFS from 0 up to 25,000. One other thing I want to do is for min flow, I'm just going to set it to, we'll just say 1,000 to be safe, because sometimes zero flow can lead to instability. I know this isn't the most natural looking hydrograph, but it's probably fine for this exercise. And once we go ahead and run the simulation and look at results, you'll probably agree. All right, that's all we need to do here. I'm going to click OK. Now we need to define the boundary condition for our gates. Now, as mentioned in the very beginning, we have two different ways to control the gates that we're going to look at in this exercise, which is time series gate openings and elevation control. There's also this navigation dam and rules. I just don't have enough time in a single exercise to go over everything. But let's start with elevation control. So I'll click elevation control gates. Now at the top, we need to specify the gate group, either gate group 1, which is on the bottom, or gate group 2, which is on the top. Let's start with gate group 1, and then this reference dropdown refers to which water surface elevation we're looking at with respect to the numbers down here. So if we just leave it here on the default of based on the upstream water surface elevation, that for us will be River Station 245 or 345, because that is the upstream edge of our inline structure. But we can also change that to a specific reference or the difference between stages. Okay, so let's just leave it there. Now for gate group 1, we need to remember that the invert of those 5 lower gates is 35 feet. So when we're asked to provide the upstream water surface elevation at which the gates begin to open, and also when they begin to close, we need to remember what those values are. So I'm going to go ahead and type in 50 and 45 feet. And that means the water surface at River Station 345 needs to get up as high as 50 feet before the gates fully open. And then it needs to drop below 45 feet before the gates begin to close. The gate opening and closing rate are right here. I'm just going to put in 1 foot per minute. And then maximum gate opening, that's going to be the total height of the gate, which is 8 feet. And then the minimum gate opening, I'm going to put that at 2 feet and then start it at 2 feet. So the gate will always be at least 2 feet open. And I'm referring to gate group 1. All right, I'm going to do the same thing with gate group 2 here. It's going to be some similar numbers, but increase the elevation a little bit by 5 feet. The gate opening rate and closing rate will be 1 foot per minute once again. And then the maximum gate is height is 8, minimum is 0, and it will start closed 0. Okay, I'm going to close that right there. And then I'm going to go File, Save Unsteady Flow Data. I'm going to call this Elevation Controlled, and then click OK. All right, looks good. So Elevation Controlled will also be the name of the plan. Let me go ahead and close this. Go to Run, Unsteady Flow Analysis. And then with the base geometry and elevation controlled flow file, I'm going to go ahead and save that plan, elevation controlled, and then click OK, and then paste that in also for my short ID. Okay, I'm going to go ahead and check on the geometry preprocessor, unsteady flow simulation, and then the post-processing. This is a 10-day simulation, so I'm just going to type in January 2020. We'll start it at midnight, and then 10 days later would be the 11th. Okay, so that looks good. All the computation settings down here look good as well. So let me save this plan data and then click compute. So it looks good. I'm going to click close now. And let's go ahead and take a look at some results. So first I'm going to go view and then cross section. Okay, interesting. Let me go ahead and change the, let's go ahead and just animate. So what we're doing here is we're going to step through each hour of the time step. And what you see here, let me zoom in a little bit on the plot. Okay, there we go. What I'm going to do instead of clicking the play button is just click through so I have a little bit more control of the speed. So the first click right down here. Okay, so we're starting off at 0 hours in the 10-day simulation. And first, we're going to ramp up to 5,000 CFS and then hold steady. So here we go. We're ramping up to 5,000 CFS, and boom, right there, we're holding steady at 5,000. Now we're increasing to 10,000 CFS, and that's 10,000. It's holding steady. Now it's increasing again, and that's a constant 15,000 CFS, increasing, and that's 20,000 CFS. This is the last increase to 25,000 CFS right there. Now it's going to start slowly decreasing back down to 10,000 CFS. So if you notice during the course of that simulation, the water surface was rising, which is the blue line right here, as well as the water in the gates. But then the gates were also opening up based on the user specified control of what the gates should do based on the water surface elevation. I think I said that right. So I can click the play button now and just let it play out. But you can do the same sorts of exercises with your own gates, your own dimensions, and also your own controls. So it's still actually running through the animation right now, but we're in the last phase, the last few days, where it's holding steady at 10,000 CFS, where the top gates appear to be closed, and we still have flow through the bottom gates. All right. So if I was going to explore this anymore, what I would probably do is go back to the boundary conditions for the elevation control gates and then change some of these values here for the lower gate set and then the upper gate set as well. All right. The next part of this exercise is to control the gates within an inline structure by using the TimeSeries gate opening control button right here. What I'm going to do is actually save a new flow file. So this is going to be called TimeSeries. I'll go File, Save Unsteady Flow Data as, and then instead of elevation control, I'll say TimeSeries, and then I'll click OK. Okay, so the name updated. Now I can go ahead and click that. Click on TS gate openings. It's asking me, am I sure? I'm going to, be removing the data that we already had in place for the elevation control of the gates. That's totally fine. I've already saved a new flow file, so that's exactly what I want to do. All right, this time we have a different dialog box, and at the top we have to select the gate group. So again, gate group 1 is my lower 5 gates, gate group 2 is my upper 5 gates. And this is really cool because I now have the option to read in a DSS path or do manual entry. So I'm going to do manual entry for this exercise, but I do like the DSS option for sure. So what I'm going to do for this exercise using the time series control is gate group 1 is going to start 50% open. That's 4 feet high. And then at the 28-hour mark, it's going to open up. Those lower 5 gates are going to open up 100% of the way, which is 8 feet. And then for gate group 2, what I plan to do is start the gate group open 50%, which is 4 feet, and then open them up 100% or 8 feet after 40 hours. And then after 160 hours, which is January 7th at 4 p.m., I'm going to close the upper gate group 50%. All right, so anyway, what I just said, let's go ahead and do that in HEC RAS. So again, I'm going to select gate group 1. This is the lower gate group. Select enter table. Now the data time interval is defaulted to 1 second, and that's kind of a small time period. I'm going to change it to 1 hour. So there's 1 hour right there. And then I'm going to use the simulation time. That's correct. And then, like I said, it's going to start half open. So I could just go 4, 4, 4, 4, 4. But I don't want to type in numbers 240 times. So I've already prepared that in an Excel file. I'm just going to copy that, Control C, and then come back to my HEC RAS here. And I think I only have 100 rows. Yep, I do. So I got to go number of ordinances. I'll just say 300. I only need 240, but might as well just go over. Now I'm going to highlight all the rows and then Control V. Let me just scroll up to make sure it pasted. It did. Okay, so half open. I said 28 hours. It goes up to 8 feet. And that's correct right there. And then it just stays at 8 until the end of the simulation, which is 240 hours right there. Perfect. Okay, so that's correct. Gate 2, I've got the same data saved on my Excel here. So I'm going to minimize that. I also need to change this to 1 hour, the data time interval. So 1 hour there. And then the number of ordinates, I need to change this to 241 or greater. I'll just say 300. All right, now let me go ahead and scroll up and highlight all the gate opening height fields and Control V. Should paste. That looks good so far. We got 4 feet, and then it's going to go up to 8 feet right there at 40 hours, and then back down to 4 feet right here, which is 160 hours. Okay, looks good. And I can actually plot this. Yeah, that's cool. So 4 feet, 8 feet, and 4 feet. And then if I go to gate 1, plot data, starts at 4 feet and then 8 feet, completely open the rest of the simulation. All right, so I'm going to click OK, and then File, and then Save Unsteady Flow Data. Perfect. All right, we're ready to run the new plan here with the time series flow file. Everything's going to be the same here except the new flow file. We're going to have the same simulation time and computation settings. I do need to save time series as my plan though, so I'm going to go File, Save Plan, Time Series, and then Save, or OK, and then OK, and Compute. Okay, so everything looks good and successful there. I'm going to click close and let's take a look at those results. So I'm going to go up to view. Let's go cross section. Let me advance to the first time period here. Options, animate. Okay, interesting. So let me zoom in a little bit here. As we're seeing at the beginning of the simulation, we have both gate group 1 and 2 are halfway open. And it looks like we have that flow right there coming in. So let me just go ahead and scroll across. So we're starting at 0 flow, and then right about here is 5,000 CFS. It's holding steady. Now it's increasing to 10,000 CFS. Now, okay, so what just happened was we passed 28-hour mark, and the lower gate group, opened up completely, and hence the water surface dropped because it can now flow more through this lower gate group. Okay, I'm going to continue on now. So we're approaching the 15,000 CFS mark. Okay. And then the upper gate group opened up 100%. That's 15,000 CFS. And then right there is 20,000 CFS. And then that's 25,000 CFS. Now it's going to slowly decrease in flow. And also the water surface elevation is also going to slowly decrease. And then pretty soon, in about a day, we're going to see the top gate group go down 50%, which is right about there. Yep, there it went. Cool. So now it's just a 10,000 CFS flow for the rest of the simulation. Well, we can go ahead and look at other results too. So for instance, if you wanted to go view and then water surface profile, let me go ahead and run the animation from here. What you're going to see is, let me just run it. So I'll click the play button. And then here we go. This is 5,000 CFS. Okay. And then right there is 10,000. The lower gate group just opened up. That's 15,000. It's holding steady. And then 20,000. And then it's going up, and this is 25,000. So this is peak flow. We're not seeing the upper gate group. I think they would be like right around here. Okay, so it's slowly decreasing. All right, let me close that up. Another view is this XY perspective plots view. And then let me just rotate here. Okay, options. Let me animate this one now. Okay, so the water surface is slowly rising. 5,000 CFS. Okay, that's 10,000 CFS. Now it's increasing to 15,000 CFS. And that is 20. And then finally increase to 25,000 CFS. All right, as always, view and profile summary data. And if we want to look at the flow through that inline structure, we could just click inline structure. And then for options, and I click profiles, I'm going to just select all the profiles, but then remove the max and click OK. Here's the flow rate right here. It starts off at 1,000. It ramps up, of course. Here's 5,000 for a while, 10,000 for a while. We see the flow through the gate, and then we also see the water surface elevation. Now, one thing that looks interesting on this particular table is I scroll down a little bit to right here. This time period is 28 hours into the simulation. I've scrolled down a little bit, so it's not the 28th row in the table at the moment. But what we see here is the water surface elevation increases from 46, 49, 50, 51, 52, 45. And the reason that happened is at 28 hours into the simulation, that's when the lower gate group opened up from 4 feet up to 8 feet. So there's much more conveyance through that lower gate group, and hence the water surface elevation dropped from 7 feet here, from 52 down to 45. think I mentioned that earlier in this results. So now we're just actually seeing some of the numbers and how that relates. Okay, well, I'm going on long enough about inline structures and gates, and specifically the two different types of boundary conditions we can assign to gates, which are right here. If I click on the gates, we talked about the elevation control gates, and then we also talked about time series gate openings in HEC-RAS.